Hello everyone, welcome back. Last week we created a simulated 3 LED animation using the Raspberry Pi Pico and our light class. If you didn't see that video, I will have a link up here and also in the video description. But basically when you run this, we get a nice little animation between the red, green, and blue LEDs over and over. Today, we're going to take this thing and actually implement it in hardware. So what is that hardware we're going to use? Of course, we're going to use our 3 LEDs, our resistors, a bunch of wires. But in order to put everything together, we will need something special, right? We don't have, at the moment at least, ability to solder things into a circuit board. That might be something we would do way far ahead in this series. Maybe if we get there. But at least today, what we're going to do is we're going to use something like this to build our circuit. So this is essentially an illustrated version of a breadboard. A breadboard, which is what we attached our Pico last time, it physically looks like this. So you will see that there are these holes that are in columns, and there is a ridge between them. So if you look at the same thing that's on the screen, and here they kind of look the same, right? So there's that ridge in between these columns of holes. And there are two sets of rows of holes on the top and on the bottom. And one of them has a red line next to it, and one of them has a blue line next to it. So the way the breadboards are internally wired is these columns of holes, they're all connected together. Okay, so imagine there is a wire that connects all of these holes together. So they're all wired together. These guys are also all wired together. And the top and the bottom are also all wired horizontally. So every one of them are connected together. Every one of them are connected together. Depending on your breadboard, they could all be in a single connection, or there may be a break between them. And this diagram is not quite correct. Typically, if there is a break between them, the actual breadboard, the color of the breadboard will show that break. This one, for example, has no break. So the red line and the blue line goes straight down, which means all of these guys are connected together. So if you put a voltage, for example, I'm doing that, pin 39 of the Pico is connected to that red line. That means this entire red line, all of these holes are connected to our 5 volts. Same thing for, if you look closely, the next pin, which is the ground pin, is connected to the blue line, which basically means this entire blue area can be used for ground. This is important because we will need that when we build our circuit. That's basically a quick introduction to breadboards. Now, some breadboards will not have these two connected. So if you want this entire line connected, you are of course going to have to put a wire in between these two so that these entire things get connected. All right, so that's enough of introduction. Let's get to building. First, let's just quickly review what we did last week. So how did we connect? Well, we took pin 3, the GP3, to the resistor. From the resistor, we went to the positive pin of the LED, which is the longer of the two pins, and the negative pin went to our ground bus, which is, that's where those blue ridge lines come into play. So that's basically, we're going to have to do that for 3 of them. Pin 3 goes to red, pin 4 goes to green, and pin 5 goes to blue. By the way, when I say pin 3, pin 4, pin 5, it's actually GPIO pin I'm talking about. They're not, as you would see, they're not physical pins because there are ground pins in between. So if you count it, GP3 is actually the 1, 2, 3, 4, 5th pin. So that could get a little confusing. That's why if you have a kit that comes with these stickers, that's really great because those actually tell you which one is GP3, which one is GP4, which one is GP5, and so forth. So that makes it a lot easier. All right, so enough of that. Let's look at the circuit board and we are going to build it. Okay, so let's connect to our physical breadboard and you will see me wiring these together. So the first thing that we're going to do is let's make sure we have everything. Again, what do we need? We need 3 LEDs. We have that right here. And just like we saw in the simulation, if you notice, look at the LEDs, one of the pins is longer than the other, right? And when it's the longer pin is the positive pin or the anode. The shorter pin is the negative pin or the cathode. And I've got a red, green, and blue. I've got a bunch of wires here and I managed to find 9 wires with the right colors that we need. Not always you will find colors exactly the way you want, so just have to manage what you can use. And then we have our resistors. Now these resistors are very tiny and of course my vision is not quite where I can actually tell these colors apart. Um, of course, in a video and in my not so professional camera, it would be impossible to see what these colors are. But these resistors are color coded. We are using 220 ohms. So the color code for that is red, red, brown. So the first 2 colors are numbers. So red is 2. So you get 2, 2, and brown, the third one is a multiplier. So brown is actually a multiplier by 10. So you get 2, 2, 22 times 10, you get 220 ohms. Now, of course, if you're like me and you can't see these colors apart, the best option would be if you have one of these guys. This is a multimeter. And what we're going to do is we're going to check to make sure these are actually 220 ohms. So let's connect these two together. And there you go. I'm getting 218, close enough. So we've got our resistor, we've got our LEDs, and we've got our wires. So first what we will do is just like we did, we will understand how the breadboard is connected. And as you saw in the illustration, all of these guys are connected together. So these are all shorted together. We need to go from pin 3, which is like this guy. It actually says 3 in the sticker. So if you have the sticker, that makes it very easy because you see 3 right there. So we need to go somehow from pin 3 to this longer of the 2 pins. So what we're going to do is we're going to poke this red LED somewhere here, and then we will take a wire, and we're not going to use a red wire. I couldn't find a maroon, so I'm going to use orange. The reason I don't like using red wire in regular circuit is red typically represents power. And since this is not power line, we're going to use orange. So we'll go from this pin 3, which is, and what we're going to do is we're going to connect it to the same column as the positive end, right? Any of these. So if you can tell, maybe very hard to see, but you would see that the orange line is in the same column as the anode pin. See, the larger pin goes into the same column anywhere. It doesn't have to be right next to it. It could have a little bit of gap. And again, the 2 pins of the LED also don't have to be right next to it. You can put a little bit of gap in there, but it's up to you. But so there is our red LED. I made a mistake. We go from the IO pin to the resistance, and then we go to the LED, right? So yeah, we're gonna have to put the LED on the other side. So we'll attach the LED later. Let's put the LED on this other side. Let's take the resistor, okay? So, but the same thing still goes. We went from pin 3 to here. Anywhere in that column, we're gonna attach one end of the resistor, so poke in the pin on one end. The other end, we're gonna poke in on the other side. And it doesn't have to be on the other side, any other column that is not directly on that one. So you can jump over the ridge to the other side because they're not connected together, so you can use that. from in that same column, we're going to take the positive end of the LED and the negative end we're going to put to the ground. We're going to put the negative end to the ground. So just like we did in the circuit, we went on pin 3 to the breadboard. In the same column of the breadboard, we connected the one end of the resistor, took the other end of the resistor and connected to the same column of the positive pin of the LED, and the negative pin of the LED, we took black wire to the ground. And we'll do the same thing for the green. So let's put the green over here. So we'll go from pin 4 to somewhere over here. We'll take the resistor, connect the resistor from that same column of the pin of the green wire into the positive end of the LED. So they have to be on the same column to be connected. And then from there, we'll take a black wire to go to ground. Okay, now notice that by ground, I mean this entire blue line is now ground because that's our ground bus, because we have connected the ground pin of the Pico into this blue line. So this entire thing has been connected. Now, of course, it goes without saying that when you're working with these wires and things like that, ideally you would want to disconnect your Pico because you don't want to be connecting wires on a live circuit. It is pretty hard to damage these things, but still it is possible. All right, so final last one for the blue one, we go from pin 5 to the one end of the resistor. You take the resistor. Let's make sure, yep, the positive pin is on this side. And then anywhere in that same column, we'll poke one end of the resistor, and the other end of the resistor we're going to put on the column of the anode pin of the LED. And then from there, we will go to ground. Now, technically, we didn't really need the ground pins. We could have stretched the LED and put it into the ground as well to save these wires. So as you get more and more confident with LED with the breadboard, you would figure out a way to optimize, because otherwise your breadboard might start looking like a jungle of wires. You want to try to keep it as neat as possible. Okay, we are done. Believe me or not. So now what we will do is we'll just test it out and see if it works with the code that we did. All right, so here we are. We have our Thonny opened up. What we're going to do is take this guy and connect it. Okay, it's connected. But of course, I don't see any LEDs going anywhere, right? Well, because we haven't put our code in yet, but that's what we will do now. So we're going to connect it to our Pico. There, we have connected, and now we see the light and the log file already there. Great, but we need one more file, right? So if you go to your simulation again, we had light log and there is the main.py. That's the file we need. The diagrams.json, that's only for the simulator. You don't need that for the hardware. So what we're going to do is we're going to copy this entire thing, and we will go in here and we're going to paste that in here, and we'll say save. We'll save it to the Pico and call it main.py. There is our main.py, and now is the time to see if it works. So what we will do is we'll have that up there. Let's see, Murphy's Law, it should work or give me an error, but let's run it and see what happens. Okay, pretty good. Our green LED doesn't seem to be working. All right, no problem. We will figure out. So this is where we will need to do a little bit of debugging. Let's see what mistake I made. So I'm going to stop this. We're going to take a close look at our circuit here. Now, debugging hardware and debugging software is, of course, a little different. Sometimes you will need to worry about if something is damaged and things like that. So we're going to run it again and see if this one works. It does not. So it was not the LED, it was just our resistor was not connected very well. Subtle loose connection. See, our green LED is pretty bright and it does work. All right, so we'll run it again and let's see how it works this time. Red, green, blue, red, green, blue, red, green, blue. Just like we saw in the simulator, now it is working on real hardware. Wasn't this fun? I hope you enjoyed this video and I'll see you in the next one.